So let's take a look at this next example. It says, according to NPR, 52% of Americans owned stocks in 2016. Suppose a random sample of 200 Americans is taken. Would it be surprising to find that 45% of the sample owned stocks? Why or why not? So first, let's check to see that the central limit theorem conditions are satisfied. They did say that it was a random sample, so we can assume it's random and independent. The expected number of successes, let's compute that really quickly. The expected number of successes is going to be 200, our sample size, times 0.52. So in other words, 52% of our sample size. And that would be 104, which is certainly large enough. The expected number of failures, you could just take the complement. You could do 200 minus 104. Or we can go ahead and just actually compute 200 times 1 minus 0.52, and that gives me a value of 96, which of course is large enough. So our sample is definitely large enough to expect 10 successes and 10 failures. And then, so let's see, yes, we expect at least 10 successes and 10 failures. And then number 3, the American population is at least 10 times. So remember our population is Americans. So the American population is certainly 10 times larger than the sample. So all 3 conditions are met, so we can go ahead and compute our standard error. So our standard error is going to be the square root of 0.52 times 1 minus 0.52 divided by our sample size, which was 200, and I'm getting a value of about 0.0353. So the distribution of the sample is normally distributed, and we can say that it's distributed, if you want to use the normal notation, normal with an expected mean of 52% and a standard deviation of 0.0353. Okay? So the question says, would 45% be unusual? So there's a couple of different ways we could answer this or figure this out. First of all, make sure you understand what the question's asking. If we pull a sample of 200 people, would it be unusual to find that 45% of the sample owns stocks? So one way to figure this out would be to think about your normal distribution and say, okay, if 52% is the mean, that's what we expect, what are 2 standard deviations below and 2 standard deviations above? And so actually compute 2 below and 2 above and see if 45% is in that interval. If you did that, 2 standard deviations below would be 0.4494 and 2 standard deviations above would be 0.5906. Well, 45% is certainly in between those numbers, so it's within 2 standard deviations. So one way to do it is to look at it that way. Another way to figure this out is to convert to a z-score. So the z-score, it's the same idea as where we've used z-scores in the past, but to figure out the z-score, the formula we're going to use is similar in structure, but it's a little bit different. And there's actually a typo on your paper. This should say p hat. So let me write that formula over here again. So the formula for z-score is z equals p hat, so whatever your sample that you're interested in this case 45%, minus the population proportion divided by your standard error. And look at what your z-score is. So in my example here, that would be 0.45 minus p, which was 0.52. Remember, that was our population proportion, divided by the standard error that I computed earlier, which was 0.0353. Now, we're going to get a negative number because the 45% is below our mean of 52%, and we get a number negative 1.98. So what do you notice? Just barely, but that number is within 2 standard deviations, right? That's within 2 standard deviations of the mean. It's at a z-score that's 1.98 standard deviations below the mean. So for that reason, we would still say no, this would not be unusual. And so remember, 2 standard deviations is our cutoff, and that's what we want to stick with in this unit when we're asked about unusual values. Okay, let's take a look at the last example. According to the CDC, the percentage of adults who smoked cigarettes in 2016 was 15.5%. Suppose we take a random sample of 876 adults and we find that 118 of them smoke. Assuming the CDC figure is accurate, find the probability that if we were to take another random sample of 876 adults, the sample proportion would be greater than or equal to 0.1347. So first of all, let's determine if the theorem applies. So the three conditions. First of all, was it a random sample? I believe they said it was, yes, it's a random sample. So it's random and independent, or we can assume independence. And then the number of successes we would expect would be our sample size, 876, times 0.155, so that's the 15.5% that I'm using. And I'm getting a number of 8, let's see, what am I getting? I actually didn't compute the number. I'm looking at my notes. I didn't compute the number, but we can certainly agree that's going to be more than 10. So we're good there. The expected number of failures, same thing. It's going to be 876 times 1 minus 0.155, which again will certainly be more than 10. So we are good to go there. And then, is the population large enough? You're talking about all adults, so yes, population is large enough. Certainly more than 10 times the sample size. So the theorem applies, and so we can go ahead and calculate our standard error. So our standard error is going to be the square root again of 0.155 times 1 minus 0.155 divided by n, which was 876, and I'm getting a standard error of 0.0122. All right. So the question says, if we were to do this again, if we were to take another random sample, find the probability that the proportion would be greater than or equal to 0.1347. So our sample, our sampling distribution is normally distributed with a mean of 0.155 and a standard error of 0.0122. This is the key information we're going to use. So then we want to know the probability that a sample will be greater than or equal to 0.1347. I highly recommend, just like I did in the last chapter, when you're working with a normal distribution, that you make a picture of it. So in the middle is going to be my expected value of 0.155. 0.1347, of course, is to the left of that. And we want to know that we're greater than that. So the area that we're interested in is this. To figure this out, I have to use StatCrunch. So what you would do is you'd go to your normal calculator in StatCrunch and you'd put in a mean of 0.155 and a standard error of 0.0122. And if I crunch the numbers in StatCrunch, I will get a probability of 0.952. And so there is about a 95.2% chance of selecting a sample with a proportion of smokers that's greater than or equal to 0.3147.